Okay, so this is going to bring us to the last part of our desire to find the coordinates for the stationary point. Remember, the whole time we're thinking about our instructions. They asked us to determine the coordinates of the stationary point and the point of inflection and label these on the graph. So they've given us a function. They've indicated that A is 10, B is 4. So now our first job is to find those coordinates. In order to do that, we use our previous knowledge of the first derivative. We use the product rule of the fourth to determine the first derivative. Over here, we determined the first derivative, and we said in order to find out what would be our stationary points, we need to see where our value is going to, our first derivative will be 0, and that dates back to our stationary points and inflections from chapter 3. So we said that E is always positive, so that's no good for us. The only other option is going to be investigating the second part of our first derivative, which is 1 minus 4x. When is that 0? At x is equal to a quarter. So we've ended up with the x value for our stationary point. What we need to do now is we need to take this x value, which is a quarter, and we need to substitute it. And by it, we mean this one. Just going to box in here in purple. We're going to take that x value and substitute it into the original function. Okay, substitute it into the original function to determine the y coordinate. Okay, I'm going to just give you the beginning for the stationary point. I'm just using that abbreviation of that. So if we're starting out with our original function, which we said on that part is equal to 10x e to the negative 4x, because we've substituted our value for b to be 4, and we've substituted our value for a to be 10. So we've got those two values. Now all we are saying is, what if my x value is a quarter? What will my function be then? Substitute as a quarter minus 4. Substitute my x as a quarter. You'd need to use your calculator, or you can use a graphics package. I'm going to ask you just to work that out. It is an investigation after all, and you're going to need to find that value for your stationary point. What you would end up with is then this answer will give you then the y coordinate of your stationary point. So your stationary point, and you'd need to be very clear about this in your investigation, therefore the coordinates, because that's the question that was asked, of the stationary points point for this function is equal to, and you'll have a value here for me, which is an x value, which we've determined to be a quarter, and a y value. Okay, now I can't work out all of the specifics of exactly every single sum in your investigation. After all, it is your investigation, but I want to give you some pointers in that direction. Because of that, I've created just a little bit of a revision note, which looks like that. I'm going to upload it to Google Classroom. It's based on the information which we have from chapter 3, which gives us the relationship between stationary points, points of inflection, and how we can use our first and second derivatives to help us find the points where the graph is going to be turning or inflecting, and the x values and the y values that we can determine from that. If you've got any questions about your specific calculations and whether you're right or not, you're going to need to just attend the Zoom session on Friday, and we'd be able to see how far you got with your calculations.